Alex is the CEO and founder of Blackthorn AI. We're hosting this event. Alex is going to talk about enterprise cloud migration, data warehousing, and analytics. Alex, the stage is yours.
Thank you, Mike, for introduction. Good time of the day. Glad to have everybody here. I will have a story, just one use case about cloud migration and data warehousing and analytics. So the purpose of this story is to share experience for people who are thinking about migration, warehousing, and analytics of the data, as well as share some insights and recommendations. I will go piece by piece, and the first one is cloud migration. And here's the case study. So the customer had a legacy system which were built on premises long time ago, and it were functioning for a long time, but recently they understood actually that they have a lot of troubles with that. Particularly, you see the troubles to the right. Major of them were that first of all, the data were stored all around. You see the disparate data sources, many of them, 1, 2, 3, 4, 5, then many separate interfaces like admin interface, then user interface, then some mobile interface, and like 5 interfaces. That's crazy. Read replicas, problems with synchronization, message queue and analytics database on another server, like suffering from the data transfer delays. And funny, but ETL, their ETL was represented by pure SQL queries run manually. And business intelligence, like reports, dashboards, and other stuff which are reported to senior management were done manually, partially manually as Excel exports of SQL queries, and then delivered by email, partially manually, and partially by automated scripts. Python, Perl, and SQL that were put on a cron schedule. So part of the queries were automatic, other part were manual, and manual queries were different almost every month. So to sum up, they had more than 100 business analysis scripts run by cron on schedule, and every week they've got about 40 custom business analysis requests that were implemented and ran manually by hand. And you can imagine if we have not one database, but more, those cannot be run in just one SQL query, but it is rather a series of queries with a temporary storing the results of a previous query, because they are very often targeted to different databases. So first you query one database, then you query second database, then you combine the results, then you try to get insights from the results of results. You can imagine how much toil and what a burden was this system. So actually, they also stored a redundant historical data just for consistency purposes, for backward compatibility, because some queries just didn't work without some tables which are no longer needed, but they are still there just for the system to work. Also, as you see, this schema is very fragile, very rigid. Another drawback is that it is run on premises. So if you wanted to scale, especially for analytics, you have to do vertical scaling manually, buying more and more powerful machines. But anyway, vertical scalability has its ceiling, and it was reached pretty much soon, so that the owners understood that they cannot grow anymore because of the system, because it takes too much effort just to maintain, and it limits their expansion. This is the business case where we started. And now, step by step, I will tell the story. So the company set the following objectives. First, migrate to the cloud, data, applications, modernize them, then build centralized data warehouse because of the data was not synchronized and the consistency was broken, which were often seen by differences in results on dashboards. Then automate this business analytics because running SQL by hand is not what we do in the 21st century. It was technical goals. As for business goals, we aimed to offload IT department, make the business more efficient, and give it full capacities for growth. I'll start from cloud migration. And cloud migration is done and was done by us in the following stages. First, we had to create vision. Then we had to assess this decision. Is it feasible from economical point of view? Choose services, evaluate choices of different cloud providers, build cost estimates, compare them, as well as SLAs of the providers to choose the optimal option. Also important was to take into account geographical location of the customer. It was a huge differentiator because many cloud providers, they don't have developed and enough capacities in those regions. Then the third stage was to enable cloud network. First, just build hybrid cloud. Set up VPN because their network was private, and build essentially hybrid cloud where some resources were on premises and some of them were on the cloud, and all of them could exchange data within one private network. Then migrate data, first by lifting and shifting the resources, then upgrading it to better services. And one of the final stages was migrate application. First, just move, Dockerize and move as they are on the serverless platforms, and then optimize them by building a Kubernetes infrastructure. I'll jump right to the results. So if you remember the schema at the beginning, remember this case? Now I've selected this bottom part because this is the data part, and I showed it took us almost a year for the team of 5 people to re-implement those applications and data into single, consistent, scalable platform, which is depicted at the bottom left. It immediately solved issues with data consistency because instead of the 1, 2, 3, 4, 5, 6 databases, we put everything into one central database, and all of these disparate applications were implemented within one Kubernetes cluster, which is known like we can scale easily. Internal load balancer distributes the load between internal resources, and the external global load balancer distributes the load depending on regions. So one cluster per one region for all these resources. Also pay attention to API management. It first of all executes security policies, then allows or denies the request of users based on their authorization status, and then routes the request to different backends and different regions dependent on the client, its geolocation, and the request. Important part is continuous integration and continuous development. By using GitHub Actions, we automated the deployment of every microservice by fact. Also, we took into account that they have low write load and high read load. So the write pods, they are no need to scale, just because we can handle it with a vertical scaling, and they don't need that much of a, they don't handle that much of load. But on the opposite, the reader pods of the same functionality, by the way, they have a very significant load. So we implemented horizontal scaling for them. But so I don't know if you appreciate, but we did a cool trick here. So usually, so this is the semi-microservices infrastructure. And the usual pain of microservices infrastructure is when the need of synchronization of writes. So that every microservices understands the state of the neighboring microservices and the state of the data. And we usually the data broker is added here, but we avoided it actually by not scaling horizontally each service and just putting everything in one queue, and also checking the data quality with some additional services such as Great Expectations and also unit testing for the procedures of the database. We also did a version of the database and easy reverting to previous schemas if something went wrong. In this way, we handled need to purchase and maintain servers because cloud took these responsibilities. We got unlimited scalability potential by deploying new clusters in new regions and just scaling up and down microservices. So like now it is infinitely scalable, and also we modernized some applications such as front ends. We rewrote them completely, and the backends were implemented in actual programming languages. So, but it appeared that it was important to track the past state of some tables, also provide a possibility for this central OLTP database to keep track of the changes of tables, as well as keep track of missing and deleted tables. This was the task that could not be handled by simple transactional database, and we need to invent something better for that. So we cleaned it up, but still we had this problem remained. Again, the database schema, it was good for storing the data and for transactional loads, but still it didn't handle the analytical loads, which was also part of the customer's request. So I put question marks here. I will continue my story to tell you how we handle that. But for now, intermediate status is that we performed cloud migration in almost 1 year. So this part has been completed, but warehousing and analytics are still something to do. Second part of the story is data warehousing. The data warehousing we did in the following steps. It is typical schema, but I draw it just from a more on top of my head, just from experience. But many books you can read something similar there. So first, so the goal is to build warehouse. Warehouse is where you store the data, but it's also a centralized storage of the data. And there are two types of the warehouses, transactional and analytical. Transactional are called Inmon, or invented by Inmon, and analytical are mostly invented by Gurbych. So we decided to build two of them actually, and I will tell you how. First, collect everything in a centralized transactional database, because most of the load anyway were transactional. But to build the schema of this database, it is good practice to start from interviewing the business and technical stakeholder on a customer side. And we did exactly that. Performed a series of workshops where we interviewed the stakeholders, collected business requirements. Then, having the business requirements, we assessed existing data sources. Remember all this stuff. What is there, what is needed, what is not needed. Carefully did lists of data sources, mapped them to requests, and started modeling. Modeling is actually building a schema of a relational database. For now, it was OLTP, as I said. And it is done iteratively. You build a part, then you review, refine, and build other part, review, refine, and build some other part until it is completed. You have the whole schema. Then you jump to decoding, then you deploy and integrate. Sounds easy, but usually might take up to a half a year. Then actually, here is the implementation of the research and stuff. So to the left, you can see data sources. Then we decided to move to Google Cloud. So ETL, we wrote ETL in data flow after some assessment of the tools and orchestrated the pipelines using the Apache Airflow. Then since the amount of the data were much lower than 1 terabyte, and for the time we were working, there were no demand for under 1 second transactional queries performed globally. So we didn't choose Spanner, but instead we went with simple Cloud SQL, because just there were no need for something more powerful. This is the storage. It is centralized transactional data warehouse, normalized in the third form, where we stored and consolidated all the data. But it handles the storage functions. Now the schema is consistent. It is not fragile, but it is hard to deal with historical data. And to deal with historical data and changes of the databases, we additionally designed the data marts. Just 2 of them are shown here, but there were much more. The data marts, according to the Kimball, they track, they have slowly changing dimensions, and they can track the changes of the different columns and tables, and even we can track deleted tables with some meta tables. We implemented all of that to track the changes. And here what we've got, it is a hybrid schema, something between Inmon and Kimball. But still, we need to implement dashboards, utilizations. To give you understanding what is data mart or OLAP cube, it looks like this. On the very basic level, it has fact and dimension tables, and also references. It is basic types. I think James did a very good job by telling this story. So I will not go deep into this. So status, at that moment, status was that we implemented warehousing. We collected the data there. We also did migration. The final thing that we had to do was analytics. Do something with all the SQLs and Excel tables and automate them, make nice and interactive. So the part 3 of the story is analytics. Here is the sequence of work for analytics. Again, workshops, asking people what they want to see on those dashboards, what triggers they want, what dropdowns they want. Then understanding what they want, we go and again, take a look into our data source. At that moment, our data source was this centralized database, so it was much easier, not this data source, right? By comparing the business demands and the available data, usually there is a chance to design cubes and an ETL required to support and maintain with data those cubes. After the design of the cubes, it is drawing exercise. This one, you just draw it. Then you code it, and then you show it. Then you show the dashboards, which works on those cubes, and show some analytics which business need. Sometimes they are accepted right away. Sometimes there are feedback or pushback, and you do more explorations, more workshops, more digging data to implement some updates, and then it is updated. And usually we move one by one, dashboard by dashboard. So the final schema looked like this. Data sources, then the first ETL of a first level implemented in data flow, which extracts, transforms, and loads data into the master SQL database, which has the read replica to offload, so that this database handle write load more efficiently, and the read replicas, they handle read loads, and the data is read from the read replica by another layer of ETLs, which transform the data and put them into the analytical storage, the data marts or those cubes, on top of which sits the data studio and creates interactive dashboards, sends email to users, creates tables, everything that they were doing by hand. Now it was automated. Pay attention that there are two flows on this diagram. In gray, it is data flow, how the data moves between sources, and finally the user receives it. And the control flow. Since activities of two layers of ETL must be strictly synchronized, we used some additional layer of abstraction and implemented attach airflow, which does exactly that. It orchestrates the first level ETL so that it puts the data where it should, it works when it should, and then only after it finished, the second layer starts and updates the cubes. An example of the dashboard, just one of the dashboard, and I retouched it to hide the private data. So apologies for this. For the quality of the image. And it took us 6 months for the 5-people team to do all that work, which I was talking about. And here the schema. Again, let me jump back to this original case. Remember this legacy system. I told that we've implemented migration of this stuff, and now I'm gonna show you that where we migrated the business intelligence and warehouse parts. So here is the schema. Now our analytical database, a set of data marts implemented on BigQuery. On top of them, with Data Studio on top of them, the Data Studio pulls data from BigQuery and automatically sends reports, emails, and keeps interactive dashboards, which users can use on their own now, which is a huge benefit. We don't have to involve our database engineers anymore for that. The SQL was implemented in 2 layers of data flow. So we can conclude that it was a happy end in a year and a half. We moved automated business analysis scripts to Data Studio with ETL, as well as custom requests. Now the users can cover their custom requests by having interactive dashboards, as well as manual exporting of the SQL results to Excel. Well, because there is a button in Data Studio, export data, and the users can export it easily. We fixed issues with data consistency, since the straight and not unbranched flow of the data. And the major point is this consistent asset transactional database with strong consistency, which is a key to synchronization of data as well as data marts. We keep track of redundant historical data by writing meta tables in BigQuery and slowly changing dimensions in the OLAP cube. We know which row was changed when, and it is used in analytics. So if we choose the periods in time, past periods in time, they automatically use the past state of the rows and tables. The schema now is consistent. It is designed both for transactional and analytical load. There is no need to purchase and maintain servers anymore because Google handles that. The scalability potential is unlimited now, and all the applications and solutions are in modern technologies. To sum up, the company now is ready for expansion, and I'm ready for your questions.
Okay, so if anyone has any questions, feel free. We're still here to answer you. On the email, we got a question regarding the application of business intelligence for the legal services, but the question was a little bit broad. So if you could potentially explain some use case which used in legal services.
Is it applicable for financial industry? Yes, of course. This is one of the industries where those reports are the most in demand, because you want to see the ROI, the growth, the profits, the salaries, the statistics, and all of that. So this is the typical use case for everybody. It's finance. I think we did that even not once for financial customers with the financial analytical loads. We did that multiple times. If you could clarify the question, what was particularly of interest, I would tell you more, but for now, I don't have enough to mention the context.
Unfortunately, it was the broad question, so I didn't get any specific. Okay, Jed, I'm allowing the microphone and.
Hello?
Hi, Jed, how are you?
Hey, how are you? Can you see me well? Okay.
Yeah, we can see you now.
Okay, great. Thank you so much for your talk. I was looking at your diagrams and they're very thoughtful. Thank you for laying it out. I know it takes so much time to make it look so good. I'm sorry if you mentioned this, Tobi-san, if you mentioned this earlier, but where does the security come in when you're with these servers and the system? Like, what is the most secure thing that you are considering when you're building this kind of migration, right?
Mm-hmm. So here I just omitted the security part at all, because I think the talk was already overloaded. So yeah, but the security in terms of this project were provided by first private networks. There were no access from external world to these networks except the devices, first of all. Second, we integrated with customers on premises by building secure VPN. And you should know that VPN encrypts data in transit, although it goes along public internet, it is encrypted. It's HTTPS. S is there. Other tools were user permissions, authentication, authorization. We didn't encrypt data on although there is an option of encryption of the data at rest, I don't think it was the case because it wasn't like severely private data. And if you know this encryption, it is additional load on read and write, because every time you read and write, you have to use encryption key just to, and then do the additional calculation. So we just skip that. Not healthcare data, not PII. Yep, thank you for the question.
Yeah, thank you so much. I'm a registered nurse and I'm building this startup called Caregiver AI. So it's definitely going to have all that healthcare data. So I see kind of like the difference there. So thank you so much.
Yeah, for healthcare, it will be different because there are HIPAA, there are other tons of compliance. I think that the requirements for data safety will be much more severe there.
Okay. So if anyone other has any questions, feel free to ask them in chat or just raise your hand so you can just a second think that.
Oh, I think Dmitro.
Yeah, Igor Bilik also has some questions. Just a second. Yeah, I'll allow Dmitro to ask.
Yeah, hi guys, it was pretty cool presentation. Maybe I missed, but yeah, you talked a lot about how you switched from migrated from complex system into some more reliable and simplified to understand from some I don't know future point of view. But can you please, if it's kind of not non-disclosable information, tell how much cost you saved if there was such option or goal to achieve within this transformation?
So first of all, it was very correctly noted that we moved from many databases to one centralized, and for that we had to redesign like everything. It was a top-down, top-bottom. We created all the schema, we assessed every data source, how the data connected, what is needed where, designed the schema, and only then implemented it, how much it costs. Well, I don't.
Basically, business just like to cost to calculate everything. Yeah. So I thought that there was a need to, I don't know, maybe through this migration, remove the complexity and decrease costs of support.
So let's take into account just a few moments. First is before the migration, they had a whole department of DBAs sitting and manually typing SQLs every day, most of them the same with some parameters that fields changed, just to supply the business with the information it wants. I know, calculate 10 people DBA salary monthly. Now you don't need them. Well, they need, but they do other tasks.
Okay, got it. Yeah.
This is the first side. The second side is servers. Do you know how much the powerful machine costs in a data center? Besides the machine, you need IT engineers and administrators just to maintain it so that it works. It's another...
Because basically I thought that the utilization of resources that were used previously were pretty good, but yeah, now I understand it was kind of not pretty good at all. Because from my experience, usually organizations just switch to cloud because it's kind of trendy, and usually they do not utilize cloud in the optimized or targeting cost-efficient way. So that was the question. Yeah. Okay. Thanks for your answer.
Thank you for your question. I think they saved even on servers because they don't need to hire people to maintain that. And salaries of people may be a big expenditures.
Okay, got it. Thanks.
So we're at the end of our event. It's been a pleasure hosting you. It's been a pleasure seeing so many people joining us. Thank you all for the questions. Thank you, Alex, for the presentation. Thank you, Eugene, James, for the presentations as well. As it was told, the event was recorded, so we will share the link where you can see when you can find the presentation by email and social media, so you will get all the links in a few days. We'll just need to process everything. Thank you a lot. It's been a pleasure.
Thank you, guys.